Welcome to AWS Network Firewall. Welcome everyone. Today we're diving deep into AWS Network Firewall, one of the most powerful network security services in AWS. I'm excited to walk you through this comprehensive guide. Over the next several slides, we'll cover everything from basic concepts to hands-on implementation. You'll learn how to deploy, configure, and manage AWS Network Firewall in real-world scenarios. Let's start with understanding what AWS Network Firewall is and why it's a game-changer for cloud security architecture. Let's begin by understanding the architecture. Here is the high-level view of AWS Network Firewall. This diagram shows how the firewall integrates with your VPC infrastructure. The key thing to understand here is that Network Firewall acts as a centralized inspection point. All traffic flows through the firewall endpoints, which are deployed in dedicated firewall subnets. Notice how route tables play a crucial role. They direct traffic through the firewall endpoints. This is what makes the inspection mandatory rather than optional. The firewall policy orchestrates multiple rule groups, giving you granular control over traffic inspection and actions. Let's do a deep dive into the core components. Understanding this hierarchy is crucial for effective firewall management. At the top level, we have the network firewall itself, which references a firewall policy. Think of the policy as the brain that coordinates all security rules. The policy contains multiple rule groups, both stateful and stateless. Stateless rules provide fast, efficient filtering based on packet headers. Stateful rules maintain connection state and can perform deep packet inspection. Each rule can trigger different actions. Allow for permitted traffic, drop for silent blocking, reject for explicit denial, alert for logging without blocking, and pass for continuing to the next rule. Traffic processing flow. This sequence diagram illustrates the exact path traffic takes through the network firewall. Understanding this flow is essential for troubleshooting and optimization. When a client sends a request, it first hits the Internet gateway, then gets routed to the firewall endpoint. This is where the magic happens. The firewall processes traffic through multiple layers. First, stateless rules for fast filtering, then stateful rules for connection tracking and deep inspection, and finally managed rules for threat intelligence. If traffic is blocked, it's either dropped silently or rejected with an appropriate response, depending on your rule configuration. Setup command sequence. Here's where we get practical. This diagram shows the exact order for setting up AWS Network Firewall. Getting the sequence right is critical for success. We start by creating rule groups because they're referenced by the firewall policy. You can't create a policy without having the rule groups ready first. Next, we create the firewall policy that orchestrates all the rule groups. Then we deploy the actual network firewall resource. Finally, we configure logging and monitoring to ensure we have visibility into firewall operations and security events. Let's dive into the actual commands, starting with creating our first rule group. Creating stateful rule groups. Let's start with creating a stateful rule group. I'll walk you through this command step by step because it's foundational to everything else. This command creates a rule group that allows web traffic from internal networks. Notice how we use rule variables. These variables make maintenance much easier when you need to update IP ranges or port lists. The rule itself uses the pass action for HTTP and HTTPS traffic from our home_net variable to any destination. The SID, signature ID, is required for tracking and reference. The capacity setting determines how much processing power this rule group can consume. For stateful rules, this typically ranges from 1 to 30,000. Let's look at the expected output and what each field means for your implementation. Now let's create a stateless rule group. These rules are processed first and provide fast, efficient filtering. This particular rule group blocks traffic from a known bad IP range. Stateless rules are perfect for this type of filtering because they don't require connection state tracking. Notice the priority setting. Lower numbers mean higher priority. This rule has priority 1, so it will be evaluated before any other stateless rules. The match attributes specify exactly what traffic this rule applies to. In this case, TCP and UDP traffic from the 192.0.2.0/24 subnet to any destination port. The AWS drop action silently discards matching packets without sending any response to the sender. Creating the firewall policy. Now we create the firewall policy that ties everything together. This policy defines the overall behavior of your firewall. The policy references both rule groups we created earlier. Notice how stateless rules have priorities, but stateful rules do not. They're processed after all stateless rules. The default actions are crucial. Stateless default actions tells the firewall what to do with traffic that does not match any stateless rules. Here, we forward it to the stateful engine. The strict _order rule order ensures consistent rule evaluation, which is important for predictable security behavior. Once this policy is created, we can reference it when deploying our firewall. Deploying the network firewall. Here's where we deploy the actual network firewall resource. This command creates the firewall infrastructure in your VPC. The firewall must be deployed in dedicated subnets in multiple availability zones for high availability. Each subnet should be at least 28 in size. Notice how we reference the firewall policy ARN from the previous step. The firewall will enforce all the rules and policies we've defined. The tags help with resource management and cost allocation. I always recommend tagging your security resources appropriately. After running this command, the firewall status will be provisioning, while AWS creates the infrastructure. This typically takes 10 to 15 minutes. Getting firewall endpoints. Once the firewall is deployed, we need to get the endpoint information. These endpoints are what we'll reference in our route tables. The describe firewall command shows us the current status and, most importantly, the VPC endpoint IDs for each availability zone. Wait until the status shows ready before proceeding. If you try to configure routes while the firewall is still provisioning, you'll get errors. The configuration sync state summary should show in _sync, indicating that all firewall components are properly configured and synchronized. Now we're ready to configure the routing that will direct traffic through our firewall. Configuring route tables. This is where the rubber meets the road. Route table configuration is what actually enforces traffic inspection through your firewall. We need to create 3 types of routes. First, routes in your protected subnets that send internet traffic to the firewall endpoints. Second, routes in the firewall subnets that send approved traffic to the internet gateway. Third, routes in the IGW route table that send return traffic back through the firewall. Notice how we use the specific endpoint IDs from the previous step. Each AZ should route through its local firewall endpoint for optimal performance. The return value of true indicates the route was created successfully. Any routing errors will show up here immediately. Multi-AZ deployment pattern. Let me show you how this looks in a multi-AZ deployment. This diagram illustrates the distributed firewall architecture that provides both high availability and scalability. Each availability zone has its own firewall endpoint, which means traffic stays local to the AZ when possible. This reduces latency and improves performance. The dotted lines show cross-AZ traffic, which can also be inspected by routing through the firewall endpoints if you need east-west traffic filtering. For enterprise deployments, I always recommend this multi-AZ approach. It's a small additional cost for significant reliability improvements. Multi-layer inspection pipeline. Now let me explain how the firewall actually processes traffic through its multi-layer inspection pipeline. This is what makes network firewall so powerful. Layer 1 provides fast stateless filtering. Think of it as a bouncer at the door. Layer 2 performs stateful inspection with connection tracking and 5-tuple rules. Layer 3 does deep packet inspection using Suricata-compatible rules that can analyze application protocols. Layer 4 applies managed threat intelligence rules. Each layer can make a final decision to allow or block traffic or pass it to the next layer for further inspection. Understanding this flow helps you optimize rule placement for both security and performance. Enabling comprehensive logging. Logging is absolutely critical for security operations. Let me show you how to configure comprehensive logging for your network firewall. We're configuring 3 types of logs. Flow logs capture all traffic flows for analysis and compliance. Alert logs capture security events and rule matches. TLS logs provide details about TLS inspection. I'm showing multiple destinations here. CloudWatch logs for real-time monitoring and S.3 for long-term storage and analysis. This gives you flexibility for different use cases. The prefix in the S.3 configuration helps organize your logs by date and type, making analysis much easier. Don't skip this step. Good logging is what turns your firewall from a black box into a powerful security tool. Monitoring and alerting. Finally, let's set up monitoring and alerting. This monitoring architecture diagram shows how all the pieces fit together. CloudWatch metrics track packet processing statistics, while logs provide detailed traffic and security information. Multiple log destinations enable different analysis approaches. CloudWatch Insights is perfect for real-time log analysis. Athena works great for S.3-based batch analysis, and custom dashboards provide operational visibility. The commands I'll show next create CloudWatch alarms that will notify your security team when important events occur. This monitoring setup transforms your firewall from a set-and-forget appliance into an active security monitoring system. CloudWatch metrics and alarms. Let me show you how to set up CloudWatch metrics and alarms for your network firewall. These commands will give you real-time visibility into firewall performance. The first command retrieves metrics for past packets. This helps you understand your baseline traffic patterns. The statistics show packet counts over time. The second command creates an alarm for dropped packets. This is crucial because sudden increases in dropped packets often indicate security events or configuration issues. The alarm uses SNS to notify your security team when thresholds are exceeded. Make sure your notification endpoints are properly configured. These metrics are essential for both security monitoring and performance optimization. Hub and spoke architecture. For larger organizations, let me show you the hub and spoke architecture with a dedicated inspection VPC. This is the gold standard for enterprise deployments. In this pattern, all your spoke VPCs connect to a transit gateway, which routes traffic through a central inspection VPC containing the network firewall. This provides centralized security policy management and consistent protection across all your VPCs, whether they're production, development, or shared services. The inspection VPC contains dedicated firewall subnets and transit gateway subnets, keeping the networking clean and manageable. This architecture scales to support very large AWS environments with consistent security posture. Configuration parameters deep dive. Let me walk you through the key configuration parameters and what they mean for your implementation. Understanding these details helps you make informed decisions. For stateful rules, capacity typically ranges from 1 to 30,000. Each rule consumes different amounts based on complexity. Simple 5-tuple rules use less capacity than complex Suricata rules. Rule actions have specific behaviors. Pass allows traffic, drop silently discards it, reject sends an error response, alert logs without blocking, and AWS forward to SFE sends stateless traffic to the stateful engine. The rule order setting affects performance and predictability. Strict underscore order is recommended for consistent behavior, especially in complex rule sets. Validation and testing. Before we wrap up, let's talk about validation and testing. This checklist ensures your network firewall deployment is working correctly. Always verify that rule groups show active status before creating the firewall policy. Check that the firewall shows ready status before configuring routes. Test traffic flows by generating known good and bad traffic patterns. Verify that logs are being generated and alarms are functioning. Monitor CloudWatch metrics for the first few days after deployment to establish baseline patterns and adjust thresholds accordingly. Remember, security is an ongoing process, not a one-time setup. Let's discuss some best practices and next steps. As we conclude, let me share some best practices I've learned from real-world implementations. Always use managed rule groups in addition to your custom rules. They provide threat intelligence that's constantly updated by AWS security teams. Implement defense in depth by combining network firewall with security groups, NACLs, and WAF where appropriate. No single security control should be your only line of defense. Consider automation for rule management using infrastructure as code tools like CloudFormation or Terraform. This ensures consistent deployments and makes changes auditable. Finally, invest in your team's skills. The best security technology is only as good as the people who manage it. Thank you for joining me on this deep dive into AWS Network Firewall.